Okay. So we've heard from Liz about the lived experience, the direct impacts of climate change. Alex has told us about a strategic view of resettlement and movement of population and the effects, short and long term, that can have. One of the other effects which came through clearly from Liz was the effect on wildlife, on animals, and for crops and food. And so it's good to turn now to Nick King from the Global Biodiversity Information Facility.
Great, thanks Ben, and afternoon everybody, and thanks for coming along. So I think we've heard a very poignant talk by Liz and then some details from Alex, and what I want to talk about is all of the other inhabitants of the planet, because they're being impacted by climate change just as much as we are. Just very quickly, my own organization was set up by countries in order to try and mobilize and share the biodiversity data so that we can start to do these global assessments of biodiversity, much as we have under the IPCC for climate, because of the biodiversity crisis. And the way that we do that is we try and build the capacity in countries and the infrastructural capacity as well as the people capacity to mobilize the biodiversity information. But the data remains with the countries in those institutions. So they simply get published to a common standard on the internet and are then accessible and globally. And this is not a trivial challenge. It's a very, very complex technical challenge to share data. You have to have political agreements. You have to have sociological changes for people to share their data. And you need all of the technical issues to be resolved as well. But I don't want to dwell on all of those things. I want to dwell on what happens once you have the information. But currently, you're able, through the GBIF portal, data portal, to access over 220, in fact, it's 260 million records now, coming from over 10,000 data sets from 300 different institutional publishers around the world, and then start to do some analyses by your search criteria of taxonomic group or geographic region and so on. Here's the diagram that Bob Watson had yesterday, and just the second column there, which is that climate change is the big pressure, the stressor, which is impacting right across every habitat and every ecosystem across the planet. I won't dwell on that much, but what is happening is that climate change is coming in as an additional stressor to all of these impacts which have already happened through human land use change, degradation, overexploitation of biodiversity, and so on. So we've had all of these compromises of ecosystem functioning and biodiversity through various habitat destructions, overexploitation. Now climate change is becoming another stressor right across that. It's not a separate entity, it's actually exacerbating all of these other issues. And we can see this simply by these exponential curves. Everything is actually starting to ramp up, and these impacts are getting faster. And it doesn't matter which of the sort of environmental issues you look at, those curves are going up into an exponential, but right across the planet. And here's the diagram Peter Kroll was speaking about, or the research, which are the planetary boundaries within which we should be trying to frame ourselves and our development. And you can see that it's actually the biodiversity one, which is in the bottom left, which is the one that we've totally exceeded, way beyond even the pressures of climate change. And I'll come back to that a little bit later. And you can see this in things like fishing down the food web, the collapse of fish stocks around the world, where if you look at that top diagram, species density of fish catchers on a standard long line went up to anything between 1 and 6 species, and today you're very lucky if you get more than 1 species on your long line. We're basically just asset stripping the oceans, and of course that has huge implications for countries and communities which are dependent on those. The TEEB report, the economics of ecosystems and biodiversity, was mentioned yesterday, and what the TEEB report is doing is showing us the economic impacts of this type of asset stripping. And so, for example, just showing that the annual cost of forest loss is anywhere between 2 to 5 trillion euros, and that is more than the total loss of the financial crisis of 07-08, and that's happening every year just in forests. And so the TEEB is saying things which should resonate with financial institutions and investors, and everything that's economically driven is just saying the security value of biodiversity can be compared to financial markets, in that the more stocks that we have and the more diverse those stocks, the more resilient we are to these types of shocks and perturbations. And that means that the more diverse biodiversity is, and the better functioning of our ecosystems, the more likely we are as human beings being able to resist these changes. In May this year, the third Global Biodiversity Outlook was released, the UNEP study for the International Year of Biodiversity 2010, and basically said that the research, the findings of that GBO3 were that if the world made equivalent losses in share prices, there would be a rapid response and widespread panic. So in other words, our stocks are collapsing, and we need to be doing something about that. I'm not going to go into the main findings in too much detail. I think everybody's pretty much aware of what's happening with biodiversity, but essentially, I showed you the exponential curves. Things are ramping up much faster. Biodiversity loss is ramping up much faster. The populations of species are declining. Many more species are moving closer to extinction. We're seeing fragmentation and degradation of forests and rivers and other ecosystems, and therefore also the loss of the ecosystem services therein. So just another example, like the fish stocks, fragmentation and loss of forests. So you see the island of Borneo there in 1950, totally forested, very little impact. And as it's progressed over the last 50, 60 years, we're down to less than 20% of that system. Now you can imagine how compromised that system is now in terms of floods, cyclones, and so on. Much more susceptible to erosion, to collapse of the system, impacts of the soil erosion on the fisheries around there, and so on. And of course, you throw climate change on top of that, on top of those already compromised systems, and you start to really see them failing. This is just UNEP's novel climate, so those areas where you'll see new climates under climate change scenarios, and areas where the current existing climate envelopes will disappear. And that's absolutely critical, and I'll talk about that a little bit later, is that we cannot manage for the current climate envelopes that sit around the world, because none of those will be there in the future, and that's really critical from a biodiversity perspective. We can map some of this. We're working with the Convention on Migratory Species on their migratory species ranges, and particularly because migratory species are transboundary, therefore they need data sharing between countries. And here's the range for the Canada goose, feeding and wintering in blue there, down south, and then breeding in all year round in the purple. And those range maps are comprised by the countries who are the range states submitting their information. And then if we put in the real-time observational data, which we're picking up through the GBIF network, we can see some huge discrepancies in those ranges. And those are being basically climate-induced, that species are moving quite dramatically. And we can pick this up both there in terms of scientific assessment, as well as anecdotally. The Royal Society for Protection of Birds is reporting records being shattered week after week in the UK in terms of seeing new species arrive. And these are not vagrants as we would know them. These are species now arriving and starting to breed. And that's birds. We're seeing it in marine systems as well, and we're starting to pick these up all around the globe in every habitat and with species right across all the taxonomic groups. And here's a very interesting one, because mostly people have projected that there's going to be a single response ecologically, which is that species will move with the temperatures to try and stay in cooler regimes. So if we look at about 370 species in the UK, right across all those taxonomic groups on the left-hand side, these studies were done on groups for which there were long-term data sets. We see that about 80% of those 300 of those species all moved north. They went with the shifting climate envelope that they had co-evolved with. But about 20% didn't. They moved south. And that went totally against what anybody expected. You know, somebody said, well, maybe the students were in the pub filling in their data sheets rather than actually doing the observations. I think we've all been there. But in actual fact, the interesting thing about this, of course, is that as you get these vast community shifts of biodiversity, the other pressures to which communities respond are shaping their movements as well. So an 80% shift north means that a whole lot of niches opened up further south for species less susceptible to the temperature or the moisture regimes. But we don't know which species are going to respond to that combination of factors. And so it's very difficult to predict how these are going to play out as climate change goes forward. But there's a number of studies showing that anyway, many species will not be able to respond like this. Obviously, they don't have the mobility. And with those compromised ecosystems, like I showed you for the forests in Borneo, it's simply not possible for species to move. So this paper by Thomas et al. Showing that probably about 50% of our global species complement is committed to extinction by around 2050. And of course, that has massive implications for our ability to adapt to climate change. We're not just talking about loss of species, but we're talking about the loss of human ability to survive, communities who depend directly on wildlife. But of course, it pertains to agricultural crops and varieties as well. And again, just work that's being done on a number of species. Here, a very temperature-susceptible species in the eastern highlands of Australia, with a 1 degree rise in temperature, that range contracts dramatically into the higher areas, and with a 3.5, boom, the species is gone. There's nowhere for that species to migrate to, even if it's mobile, because the mountaintops just close out. Similar findings on other species which are altitude dependent or temperature dependent, butterfly species. Butterflies are great indicators because they're short-lived and they are very easy to monitor. And you can see in the left-hand graph here, these were the populations back in the late 60s and 70s, where the red triangles are. And then the white dots are where those populations are no longer found in those mountains. And the black is how the range has contracted, the suitable range. And you can see in the bell charts how the species has moved up the slope. And we're getting this for a number of species, no matter where they're being assessed around the world, quite dramatic movements for something as small as butterflies. Average movement uphill, about 220 meters, average temperature increase about 1.3 degrees in their original habitat that they're trying to escape from. And average area loss of 1/3 already in the last 30 years, so quite dramatic changes there.